Hello students, today we are going to talk about chapter 1 rational numbers for class 8. This is taken from Ncert book. Okay, so in class 7 we had studied what are integers. So in class 8 we are going to study about the rational numbers. So first let us try to understand what is a rational number. A rational number is of the form P by Q where Q is not equal to 0. That is a standard definition, and P and Q should be co-prime to each other. You must be knowing the concept of co-prime. They are not having any other factors apart from 1. And okay, fine, we know technically what is the definition of a rational number. Through another definition we can say when P divided by Q, when the quotient is such that it terminates or it reoccurs, so then it will be a rational number. Okay, so first let us understand what was the need for a rational number. Okay, let us come to the first property as well, and let me explain you the concept also. The first property is closure property. Okay, so in class 7 also we had studied what is closure property. So closure property is something over a operator. Okay, operators are plus, minus, multiply, divide, all these are operators. Okay, so we'll check for closure property over these operators. Okay, it could be over natural numbers, whole numbers, integers, or rational numbers. Okay, so in class 7 we had studied up to this. Okay, and in class 8 we are going to study on rational numbers. So closure property is when you now closure property over addition would be when you add two numbers, say 2 plus 7, the result is 9. Okay, so 9 is also a natural number. That is, when you add two natural numbers, the result is also a natural number. So natural number would be closed under addition operator. But if we do 2 minus 7, that would give me minus 5. Minus 5 is not a natural number. It's neither a whole number. So it is not following the closure property for subtraction. Again we come to multiplication. This will give me 14. So that is a natural number. So multiplication will be following the closure property. Now over natural numbers. Now if you do 2 by 7, again this will not give me a natural number. Okay, so in case of natural numbers as well as whole numbers, addition and multiplication would be closed, subtraction and division will not be closed. Okay, if we look at integers, as we had studied in class 7, when we add two integers the result is also an integer. Okay, when you subtract two integers the result is also an integer. When you multiply two integers the result is also an integer. But when you divide two integers the result is not an integer. So it will not be closed under division, but will be closed under addition, subtraction and multiplication. Okay. Now let us look at rational numbers. Rational number is of the form P by Q. So let us take such an example. Say 2 by 5 plus 7 by 3. So the result has to be a rational number. Let us see. 5, 3, the LCM is 15. So this becomes 6 plus 35. That becomes 41 by 15. So the addition gives 41 by 15. Now Q here is not equal to 0 and they are relatively co-prime to each other. So it's a rational number. Okay. Now let us see for subtraction what happens. Suppose we do 2 by 7 minus 5 by 3. So this will give me 21. 6 minus 35, that would give me minus 29 by 21. Okay, so again Q is not equal to 0 and they are relatively co-prime to each other. So overall it would give me a rational number. 2 by 7 into minus 5 by 3, that would give me 5 2s are 10, minus 10 by 21. So again 21 not equal to 0. So this will also give me a rational number. Okay, 2 by 7 divided by 5 by 3. Now, interesting thing to look over here is when you do 2 divided by 7 whole divided by 5 by 3, it is same as 2 by 7 into 3 by 5. Okay, so that would also obviously give me 6 by 35, which is not equal to 0. So whether you add, subtract, multiply or divide, we think it's under closure. Now let me bring another example over here before we conclude anything. In case of division, 0 is a rational number, right? Because what is 0? We can write 0 by 1, that is same as 0. So denominator is not equal to 0. So technically it's a rational number. Now if we do 2 divided by 7 whole divided by 0, that means anything divided by 0 is not a rational number. So that means what? Division is still not following the closure property. Okay, so for closure property, addition, subtraction and multiplication are true, but for division, closure property is still not being followed by rational numbers. Okay, now let us come to the next rule. Okay, so before coming to the next rule, I would like to say, now in case of natural numbers, it was following closure over plus and multiply. Okay, for whole number it was same, plus and multiply. Okay, then came integers, it was plus, minus and multiply. So for division there was still something left over from integers. Okay, so that is why we needed rational numbers. From natural numbers there was something left over, that's why, like, you do a certain operator and there was something that we could not get the answer in that part because it was not closed. So that's why there was a need for whole number. From whole number also we could not get a complete answer on the number line. Okay, so that is why we needed integers. Even with integers, when we divide two integers we are not getting an integer, so there is a need of another thing in the number system. So that was the rational number. So here also plus, minus, multiply, they are satisfying. Division is almost satisfying except 0. Okay, so that helps us to understand that there will be something else also in the number line. Okay, and there are other concepts also, so that we'll be studying in higher classes. So now we understand what is the meaning of using the word closure. So now let us come to the next property, that is known as commutative property. Commutative property is the order of the operation doesn't matter, as in a plus b, whether you add a first with b or you add b to a, the answer will remain same. So when the order of operation does not matter, then it follows the commutative rule. So a plus b is same as b plus a, but a minus b is not same as b minus a. Let us take an example. Say 2 by 3 plus 4 by 7 will be same as 4 by 7 plus 2 by 3. We can take this example, LHS. So this would be 21 and this would be 14 plus 12, that would be equal to 26 by 21. Let us take the RHS, that would be again 21 and this would be 12 plus 14, which is again 26 by 21. So LHS equal to RHS. So that means addition is following the commutative rule. But what about subtraction? In case of subtraction, say 2 by 3 minus 4 by 7, what will happen? Let us take the left hand side first. So 21, 14 minus 12, that is 2 by 21. Okay, now if we do 4 by 7 minus 2 by 3, that means we are reversing the order. Then what happens? 21, 12 minus 14, which becomes minus 2 by 21. So LHS is not equal to RHS. So subtraction is not following the commutative rule. Okay. So here is one tricky thing that I want to ask you. 2 by 3 minus 4 by 7 is same as 2 by 3 plus minus 4 by 7. Now if we change the order of these two rational numbers, the answer would be same. But what are we trying to prove? The commutative rule over negative operator. Here I have changed the operator to plus. So doing the commutative over plus and minus, they are not the same thing. Okay. So be very clear on this particular part, that what is your operator. If the operator is plus, it will follow the commutative rule. If the operator is minus, it will not follow the commutative rule. Let us see for multiplication. 2 by 3 into 4 by 7. So that would be 8 by 21, and 4 by 7 into 2 by 3, that would again give me 8 by 21 only. So multiplication will also be following the commutative rule. Okay. Now let us look for division. 2 by 3 divided by 4 by 7, that would give me 2 by 3 into 7 by 4, that is 14 by 12. However, if we change the order, 4 by 7 divided by 2 by 3, that would give me 4 by 7 into 3 by 2, that would give me 12 by 14, which is LHS is not equal to RHS. Okay, so division will not follow the commutative rule. Okay, now let us come to the associative property. That is the third property, is associative property. Associative property is A plus B plus C. This would be same as A plus B plus C. As in, there in commutative it was about the order. The order doesn't matter. Here, association with any of the two operands, that will not alter the result. So in addition, we'll see associative property will be followed, but in subtraction, associative property will not be followed. In multiplication, again associative property would be followed, and in division it won't be followed. Okay, now let us come to the role of, there is another property also, distributive law, that I'll be telling in some time. Okay, let us understand the role of 1 and 0 over here in entire number system that we are going to do. So whenever you multiply something with 1, the result would be the same number, and whenever you add 0 to any number, it will give you the same number. Okay, so the concept of additive inverse is you add a number with another number, okay, such that overall result is 0. And in case of multiplicative inverse, you multiply one number with such a number so that the result is 1. Okay, so let us take an example of additive inverse first. Suppose we have got 2 by 3. Okay, so you add with such a number so that overall result is 0. So I'll take that number to be x. Okay, so what would be x? If you see from linear equation point of view, this would be going on the other side, so it is plus sign over here, so overall it becomes minus. So it becomes 0 minus 2 by 3. We'll be studying about linear equation in chapter number 2. So it would be minus 2 by 3. Now, so put it simply, additive inverse is whatever is the number, you just put a minus sign in front of it, and that is the additive inverse. Okay, let us take example of minus 1. So additive inverse of minus 1 will be minus of minus 1, which would be equal to 1. Okay, additive inverse of say minus 5 by 3, that would be equal to minus of minus 5 by 3, which would be 5 by 3. So additive inverse of any number is just by putting a negative sign in front of that number. Okay, by the way, let me tell you, minus 5 by 3 or 5 by minus 3 and minus 5 by 3, they all are same numbers. Okay, don't get confused that okay, minus is in front of numerator or denominator. The sign does not belong to numerator or denominator like that if it is in a single term. Okay, it belongs to the overall number. Okay, when they are in single term, remember this. Okay, now let us look at multiplicative inverse. Suppose you have a number 3, you have to multiply with such a number so that overall result is 1. So that means 3 goes on the other side as per linear equation term. So x will be equal to, it is in multiplication, so if it goes on the other side it becomes in division, that is denominator. So if you multiply 1/3 into 3, the overall result will be 1. Okay, so the rule for multiplicative inverse is whatever is the number, you just change the numerator and denominator. In this case it was 3, that is 3 by 1, so that becomes 1 by 3. Just reverse the numerator and denominator. What will happen? Achha, suppose let me take another example, minus 4. So in case of minus 4, what will happen? Minus 4 means minus 4 by 1. So the multiplicative inverse will be 1 by minus 4. In case of multiplicative inverse, the sign doesn't mean that it will become 1 by 4. It will be 1 by minus 4 or minus 1 by 4. Okay, so minus 1 by 4 is the multiplicative inverse of minus 4. Only when we are doing additive inverse, then only the sign changes. When we do multiplicative inverse, then the numerator and denominator changes and the sign does not change. Okay, let us take an example, say minus 1. What would be the multiplicative inverse of it? Minus 1 is what? Minus 1 by 1. In this case, what happens? It remains 1 by minus 1. So multiplicative inverse of minus 1 will remain minus 1. This is an exception. Another exception is 1 itself. 1 is 1 by 1. Reverse them, it will be 1 itself. Okay. So 1 and minus 1 are two such numbers where the multiplicative inverse is the same. And in case of additive inverse, what happens? When you are adding 0 with 0, the result is 0. So 0 is a number where the additive inverse is same as the original number itself. Okay, so I think that is it for now. By the way, let me add certain thing more. Have you heard of the word reciprocal? Reciprocal is basically reverse. Okay, so does it mean inverse and reciprocal are the same things? Reciprocal means you just reverse it, and inverse means there also we are inversing something. In additive inverse, we change the sign, and in case of multiplicative inverse, we inverse the numerator and denominator. Okay, so reciprocal is actually not exactly same as inverse. Reciprocal is equivalent to multiplicative inverse. So reciprocal is not equal to additive inverse. Remember this one. So whenever they say find the reciprocal, basically they mean find the multiplicative inverse. So you will just change P by Q to Q by P. Okay. And additive inverse is just put a minus sign. Okay. So that was about the 0 and 1, how they are special. Now we'll talk about the distributive law. Distributive law is over multiplication for the addition. So A into B plus C. Let us take a number also, that would be easier. 2 into 5 plus 7. Okay. So this can be written as A into B. Then there is a plus A into C. So A into B plus A into C. And the reverse is also true. If there is something common between both of them, we can write it as A can be taken as common and we can write B plus C. So here let us see 2 into 5 plus 2 into 7. Okay, so that would be 10 plus 14. Now if the reverse were given, say 2 by 5 into 7 by 8 plus 2 by 5 into 3 by 7. So in this case, what will happen? 2 by 5 is common in both of them. So we'll take out 2 by 5 as common according to the distributive law. What is left over from the first part? 7 by 8. What is there? Plus sign. And what is left over from here? 3 by 7. Now we'll simplify the internal part and then we'll multiply with 2 by 5. And whatever is the answer, we'll just put it out here. Okay. So this completes our chapter. There's one more small part, that is representation of rational numbers on number line. Okay. And how we can put say 5 rational numbers between any two rational numbers. So those are pretty easy. Okay. For example, if I am given a rational number, say 2 by 5 and say 7 by 8. Okay. And we are asked to put three rational numbers between these two. So what we'll do, we'll take the LCM of 5 and 8. Okay, LCM of 5 and 8 would be 40. So 2 by 5 into 8 into 8, 7 by 8 into 5 into 5. That would give me 16 by 40 and this would give me 35 by 40. Now how many rational numbers we needed between them? 3. So we put any 3 of them. 17 by 40, 18 by 40 and 19 by 40. If we need more, we can put more also. Okay, so between any two rational numbers, there can be many rational numbers that we can put. Okay, so even if you are asked to put 90 rational numbers between any two rational numbers, you can do that. Okay, so we'll be doing exercise 1.1 in the next video. Okay, and even exercise 1.2, the representation part, in the same next video. Okay, thank you for watching this, and in case if you have any doubt, you can put it in the comments and I'll get back to you by explaining those concepts also. Thank you for watching it, and if you really like the video, if it helps you, then do subscribe to it and you can like the video also. Thanks a lot.